Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we go through the hypergeometric distribution. So this is another alternative to drawing long tree diagrams. We looked at the binomial distribution, which is a quick way to calculate probabilities when it's with replacement. Well, this formula that I'm going to go through in a second, this is how we quickly calculate something that's without replacement. So it is a complicated formula. So there are four variables here. So big N is the total number of objects you start with. K is the number of those objects that have a certain feature. Little n is the number I'm actually picking, and little k is the number I actually want. So I use this formula. Notice it involves combinations, and this will give me the required probability. Now, it probably doesn't make a lot of sense, so let's look at an example. So this is the sort of question for which we would use the hypergeometric distribution. So let's say Mr. Luck has a bag of chocolates, contains 6 Mars bars, 5 boosts, 4 crunchies, and I'm going to pick 4 chocolates from this bag, one after the other without replacement. So if I pick a chocolate, I don't replace it with an identical one. What's the probability I pick exactly 2 Mars bars? So for these kinds of questions, we've been using a tree diagram. But a tree diagram here wouldn't be helpful. It'd take forever. The number of branches, because each time there are 3 possibilities, Mars bar, boost, and crunchy, and I'm picking 4 chocolates, the total number of branches would be 3 to the power of 4, which is 81. It would take forever to draw a tree diagram. So instead of that, we can actually use this formula. So the tricky part is just understanding the formula, what all the letters mean. So N, big N, is the total number that you start with. So in the bag at the start, there were 6 plus 5 plus 4, there were 15 chocolates. So I'm talking here about Mars bars. So Mars bars is the certain feature that I'm talking about. So big K is the number of Mars bars in this case, because the question's asking about Mars bars. So there were actually 6 Mars bars. So little n is the number I actually choose. So I'm picking 4 chocolates in total, and little k is the number of big Ks that I want. This is the number of Mars bars I want. So the question asks 2. So I can just substitute these numbers into this formula up here, and it will give me the probability without needing a tree diagram. So it will just be big K, choose little k, times n minus k. So n minus k is 9. That's the number of chocolates that are not Mars bars. Choose, and little n minus little k, 4 minus 2 is 2. Okay, so this is saying I want to pick 2 Mars bars from 6, and I also want to pick 2 non-Mars bars from 9. That's what this question's asking here. 4 chocolates, 2 Mars bars, 2 are not Mars bars. And then what goes on the bottom? 15, choose 4. That's the total number of combinations, the total number of ways that I can pick 4 chocolates out of a group of 15. So all I need to do is put that on my calculator. So if we put this in a calculator, we get approximately 0.4. So that's the probability I'd get 2 Mars bars and 2 non-Mars bars. So again, the trade-off here is the same as for the binomial distribution. The formula is harder to understand, but if you understand the formula, it's way quicker doing it like this than drawing a tree diagram. All right, I'll do one more example. So let's try this question here. I pick 5 cards from a normal deck of 52, one after the other, and this is without replacement. What's the probability I pick exactly 1 heart? So once again, could draw a tree diagram. This, each time I pick one, it has 2 possible outcomes, heart or not a heart. So the total number of branches, if I were to draw a tree diagram, would be 2 to the power of 5, which is 32. That does take a long time to draw. Instead, I'll use this formula up here. So big N is the total number of objects you start with. So in a deck of 52, big N is 52. That's how many cards you start with. Big K is the number with a certain feature. Here, the feature I'm interested in is that it's a heart. So there are 13 hearts. 1/4 of the deck is hearts. So little n is the number I'm actually picking, so in this case 5, and little k is the number of, in this case, hearts that I want, which is 1. So I can just substitute these straight into the formula. So big K choose little k, times n minus k, which is 39, choose little n minus little k, over big N, choose little n. So what's this saying? So this is how many ways that I can pick that one heart. Of course, that will just be 13 because there are 13 hearts I could pick. This is how many ways I can pick 4 cards from the other 39 that are not hearts. And this is the total number of ways that you could pick 5 cards from a deck of 52. So again, we just need to put this on our calculator. So putting it on our calculator, we get about 0.41. So if you pick 5 cards from a deck without replacement, there's about a 41% chance that you will get 1 heart and 4 cards that are not hearts. Again, I know this is a tricky formula to understand, but if you do understand it, it saves you lots of time from having to draw tree diagrams. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.